Hello. Today we are going to discuss on most important topic of artificial intelligence and machine learning, known as the neural network. So we are going to discuss today neural network. Let me take it a little bit in left. In that way, neural network. We are going to discuss neural network. Okay, known as NN. Sometimes this is also called the ANN, which stands for artificial neural network. ANN, artificial neural network. So what does this thing do? Neural network does what thing? So neural network is a data-driven method. It is a data-driven method. Data-driven method which is used for classification, prediction, and feature extraction. Computer science people say feature, we statisticians say as a variable. So this is the main purpose of the neural network. Okay, so neural network is a data-driven method which is used for classification, predictions, and feature extractions. Okay, how does neural network work? So how does neural network work? Okay, so suppose this is a human being. Okay, so if this person received a pinch or a punch or a prod or maybe hit by some other things from the back, then the guy will immediately understand, because his brain, his neuron from the brain will suggest him that this is a pinch or this is a punch or this is a hit by a rock or this is something like that. So the way human brain works and give a suggestions, make a decisions based on some events that happened inside his body. So exactly same way, how can we model those type of activities that human brain can respond? How can we express those things in terms of mathematical model? That is what that's the way neural network work in mathematical formulations. So the way human brain react, we want to model that things in mathematical way. Okay, so this is the way real life problems we can solve, like the way our brain, our neural in the brain, they can come up with the decisions after getting a after getting a uh, after getting a after receiving a uh, after receiving a like a call, or after receiving uh, some kind of heat or some kind of pinching, punching, how brain come up with the decisions that this is a pinching, this is a punching, this is a prod, or this could be a heat by a rock, something like that. So the way human brain work, we want to express those things by mathematical model, and that is what called the neural network. Okay, so the learning and memory properties of neural network resemble the properties of human learning. So the way human learn, exactly same way, like the learning and memory properties of neural network resembles. So they also have a capacity to generalize uh, from particulars. Okay, so this is what how neural networks work. So this is like one thing that I discussed. What is neural network? What neural network does and how neural network work. And now number 3, I want to discuss concept and structure of neural network. What is the concept? Concept and structure. Structure of neural network. So neural network, there is a number of predictors. So suppose these are the outcome, and there is a number of predictor. Okay, this is a x1, x2, and goes up to xn. So concept and structure, how how like the neural network works, and what is the concept? Concept is that by combinations of the predictor variables, neural network try to find the relationship among among predictor predictors, as well as among predictor as well as relationship relationship between outcome and predictor. Outcome and predictors. So this is the main structure. Now, how this could be done? Relationship between outcome and predictor, how that could be done. So neural network structure is what? Structure or concept. There is a number of feature, that means predictor variables. There is a predictor, and there is like establishing or finding a relationship among predictor as well as relationship between predictor and response variable. So you know, in linear regression or logistic regressions, there is a linear relationship, or there is a sigmoid relationship in linear and logistic regressions. But there is no specific type of predetermined relationship that we declare before running the neural networks, before running the model. Instead, in neural networks, they learn what type of relationship exists by from the predictors, by running, by including some, it is called the activation function, and then there is a called input and output things. They try to learn the relationship and finally establish the relationship by making a number of iterations. That is the neural network structure work. So like the linear regression, which is a predetermined linear relationship between variable, and logistic regressions, which is a kind of sigmoid relationship, like this, like that, sigmoid relationship, something like this. But so this is the type of regression. But in neural network, we do not know what type of relationship between predictor and outcome variable. Instead, from the data, we try to learn. And finally, after learning by a series of iterations, we come up with a relationship between this. So that is the concept. Okay. I have uploaded a handwritten note in addition to some PowerPoint slides and this video. And also the textbook that was written by the Willy, data mining for business analytics, something like that. Read that chapter, then you will get all the concepts. Okay. So we will do a simple, very simple, with a very limited number of 5 observations. We will do these things in order to clarify the mathematical concept or mathematical model. We will do that. Okay. So neural networks has certain things. Those are known as the nodes, input layer, and then hidden layer, and finally output layer. Okay. And also there is biases theta I and then weight Wi. These biases and corresponding to each node, these biases and Wi starts with at the initial gas of very initial gas of very small random numbers. Initial guess of very small random numbers. These weights are given initially, and then in later stages, after updating, we will update these things. Okay. So there is a there are some ideas that I have written in here. There is a nodes, input layer, hidden layer, and output layer. Input layer at each node is the output layer for the next stage or next things. And there is also a activation function. Activation function. There is also a activation function. So these are the concept we are going to use in order to classify a problem. Okay. In order to classify a problem. So let me write the problem, and then from there, so what I am going to do now, we want to discuss a small problem with a 5 or 6 data point, and we want to explain each of these, like what is node, what is input layer, what is hidden layer, and what is the activation function, what type of this, how theta I and Wi are computed at each stages after the initial guess. Those are the things now I am going to discuss. After giving a small example, then I'll go to the Python code. From the Python code, I will run a small problems, one is small problems and another one is big problem. So if you understand the Python code, so your homework will be very easy. Okay. So let me start writing this thing. Suppose I have a observations number, observations in here, which is 1, 2, 3, 4, 5, and 6. This is the observation number. This is a fat scores, and that is a salt score. And then this is a acceptance. What is the fat score? 0.2, 0.1, 0.2, 0.2, 0.4, and 0.3. And this is a 0.9, 0.1, 0.4, 0.5, 0.5, 0.8. And this is a like. This is a dislike, 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 like, and like. What does this mean? There are 6 companies which produces cheese, And on the basis of fat score and salt score, we want to know how we want to predict whether this is acceptance or this is a rejection. That means this is people like it or people dislike it. So this is a very simple example. So in this model, if we want, we can write this in the following format. Let me see, where did I write it? Yep, I write it in here. I write it in here. So let me write it in this format, then you will understand. So I want to give it a like this. And we want to put here N1, neuron 1, and this is a neuron 2, N2, N1 and N2. So this is known as the input layer. This is known as the input layer, and that one is known as the salt. This one is known as the fat. So there are 6 values, 6 things is coming in this way. Okay. And there is the hidden layer. There is a hidden layer. I want to write here hidden layer. Each of this rectangle is known as the node. So in this hidden layer, we want to consider 1, 2, and 3. So this and 3 and theta 3. This is N4, theta 4. This is N5, theta 5. Okay. So from there, I want to go like this. I want to go like that. And then I want to go like this. 1, 2, 3, 4, 5, 6. From there, I want to go like this. I want to go like that. I want to go like this. Okay. So now this is the way. This is W13, then W14, then W15. And this is the W23, W24, and W25. These are the weight, initial weight we are going to use. This weight will be generated completely randomly. Okay. This is called the hidden layer. This layer is called the hidden layer. So from there, we want to predict, that is known as the output layer. So which should be N6 and theta 6. Okay. So that is known as the output layer. That is known as the output layer. And then we want to make a decision whether this one is like or dislike. How? We will have a numerical value corresponding to that. That numerical value, if greater than 0.5, that means more than 50%, then it is like. If it is less than 0.5, that means less than 50%, then that is dislike. So how many ways this could be gone? From here, I want to come in there. From there, I want to come in there. And from here, I want to come in there. So these are the new ways. It is known as the W36, W46, and W56. Okay. This initial weights will be given. From there, we have to compute the final value, which I'm going to compute now, and then you will see the results. Okay. You will see the results. Okay. So now, after doing one iterations, then we have to, I am showing just only one cases running, but some cases you have to do the again backing and then updating weights and then biases, not biases. Then you have to again refine those computations in order to get the final result. When we will stop these things, like refining these things, when the successive values difference are very, very minimal, very small, then we will stop this. Okay. So now take a look at that. What did I say? This is called the node. 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 NODE node. And this is called the weights. Okay. These theta are called the biases. Biases for each node. These theta are called. So please read the documents. If you read the documents, then things will be way easier. Rectangular represents node Wij on arrows or weights. Theta j inside nodes are the bias values. Okay. So the input, now let us compute these things. So the input, instead of drawing, should I draw these things? Okay. For example, if I now draw these things, how does this looks like? Now, let me draw by plugging the value so that you will understand how the paper and pencil computations are done if I plug the value. So in the salt, if I put here salt, and if I put here fat in there, and then that fat and salt, that one is N1 first node, which has the value 0.20. That one is N2 salt 0.90. How did I get that 0.20, 0.90? This is the 0.20, this is 0.90 for the first one I have taken. Okay. Now from there, I want to consider three node, node 1, node 2, these three. Okay. So now I want to write here. Okay. Then these are the initial weights I want to consider from here. Here to there, here to there, and here to there. So this is W13, which I consider as 0.05. Okay. Then W14, I want to consider here negative 0.01, negative 0.01. And then that one I want to consider W1 31415 equal to 0.20. Now I want to consider here to there 1 and then 2 and then 3. Again, these W, that means weights, are initial weights completely picked up randomly that has very small values. That's the assumptions of running or using neural networks. Okay. So, and then similarly, this one I want to put W, let me put there. I should put there. Let me put there. Here. This is W 2, 3. And then this is W 2, 4. This is W 2, 5. These weights are given as 0.01, 0.03, and then negative 0.01. Negative 0.01. These are the weights. And then corresponding value is in here, N3. This is node N3. N4. And then negative N4, N2, N4, and N5. Okay. I want to now compute how these values will be computed. Here, the value is 0.43. Here, the value for the fourth node is 0.512. 512, and then here the value is 0.52. How these three values computed, now I'm going to show that. And in this one, there is also, like, as I mentioned to you, theta 1, theta 2, theta 3, those are the values that is needed. We have to plug those value in here. So theta 3 equal to 0.3, and 13 equal to 13 equal to 0.05, 0.0123, 23 equal to, okay. So theta 3 equal to negative 0.3, and this is the given. Okay. So now come in here. If I compute 1, then you will understand how. So N3 how computed? How N3 equal to this value? Let me write in here. How did I get this N3 value equal to point? So we have to use here a activation function. That activation function will have a mathematical formula e to the power minus, and then I have to write here that formula. Let me write that formula in here. Here is the formula: theta j plus w I j x I, and then I goes 1 to, in this case 2, I goes 1 to 2. Okay. Now take a look, how did I compute this value? How this is equal to that? If you plug 1 plus e to the power minus theta j, right? In the theta j, which is equal to theta 3 in our case. In this case, it is N3. So this is theta 3. It is theta 3. So theta 3 equal to, our theta 3 equal to negative 0.3, negative 0.3. Now come in here. Wij, right? Wij. J equal to 3. So that means 1, 3. So I equal to 1, I equal to 2. If, and then j equal to, here j equal to 3. Because now I am computing third node. I'm computing this third node. As I'm computing third node, it should be W1, 3 and W2, 3, and then X1 and X2. Those are the values. If we plug, then we are getting here 0.05 times 0.2, 0.2 plus we got 0.01 times 0.9. Okay. So this is what we have now. So if we plug all of this, we will end up with 0.43. So I have shown you how to compute this one, and these theta 3j values are given. So let me write in here, theta 3 equal to given as like this. W13 will be given. Given means initially very tiny, very small, random value close to 0, very tiny, very small values. So 0.05, and then theta 24, 24 equal to 23. Let me see, 132, yeah, 23. J is fixed, 23 equal to 0.01. These things are given. By using these things, I have computed that one. I have computed that one. This one has been computed. Okay. Similarly, we have to compute 512 and 0.52. Okay. After doing this, so in details, all of these computations are given on the page number. Let me count the page number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the page number 11 in details in my handwritten note, on page number 11 in my handwritten note, page number 11 on handwritten note, I explicitly explain how this number come to an existence, like how this number 0.43, 0.512, and 0.52 are computed. Okay. Now, after this, once these computations is done, then we have to do the final computations. Final computations, in order to do, we have to again have some weight value in here, which is equal to 0.10 and then 0.50 and then 0.15. Okay. So now the question is, first initial weight is given. How can I update this weight? Is it again given, or there is a formula for updating that weight? What is that formula? In order to update the weight, the formula is this. So in order to update this, the formula is, okay, so updating formula is this. This is the error. K is computing yk. This K is node. So that means node in K, which is equal to 1 minus y hat K, and then yk minus y hat K. After doing that, then you theta j new. This is when you will go for the second iterations or third iterations, something like this. Then this is the way you can update your weight. Okay, this is the formula. The weight is updated. Now go to that problem again. And then finally here, we compute 0.506 corresponding to node N6. And our theta is in here. Theta 3, theta 4, theta 5. That will be the theta 6. So that theta 6 is computed or given or updated, which is equal to 0.015. And then finally we got, by using same formula, we got this. So this number is greater than 0.05. So our first decision is like. Our first decision is like. Now I want to explain these things. Again, there is a coming back in this case, and then all of these weights and thetas, biases are updated and then refine those things in second iterations, third iteration, fourth iteration, fifth iteration. This is done continuously up until successive iterative value has a very minor differences or they convert, something like this. So that is the idea of the neural networks. So I explained in here, what is uh, uh, activation function is. So this is our activation functions that we use for computations. This is the activations function. And there is a, there could be just a linear activation function. There could be exponential activation functions. There could be logistic exponential functions. But this activation function must be monotone. Monotone means it should be like this, like monotone functions like this. There should not be any like discontinuity or like there is a non-monotone function. Okay. So this is the way you finally address that whether you predicted things is a classified or not classified correctly. In our cases, it is classified correctly. Okay. I think that is the main idea. Now, let me go to the R to show you how all of these computations is done. Neural network actually perform way better for the discrete variable or categorical variable. Let me read something from there. So when using a logistic function, so you can use exponential activation function, linear activation function, and logistic activation functions. Let me read something. When using a logistic activation function, neural network perform best when the predictors and outcome variable are on a scale 0 to 1. If predictor and response variable are in the scale 0 to 1 and logistic regression activation function are used for classification, in such a cases, it is necessary to transfer all continuous variable or all categorical variable in the scale of 0 to 1, in the scale of 0 to 1. Okay. So when using a logistic activation function, neural network perform best when the predictors and outcome variable are on a scale 0 and 1. For this reason, all variables should be scaled to a 0 to 1 interval before entering them into the network. For numerical variable x, suppose if your variable numeric x is numerical, that means in continuous scale, in such a cases, there is a transformations that should be used in order to transform the numerical or continuous variable to a 0 to 1 scale. Okay, 0 to 1 scale. So let me take you now to the Python code. Let me take you to the Python code. So these are the software we have to run. And then I also run the code, which is line number 9, which specify the directory where my tiny data is located. So, and then I run the line number 11. On the 11, there is a tiny data example underscore df. This is the data, observation number, fat score, salt score, and acceptance. Okay. Previously, I showed you how to compute those things by using paper and pencil approach. Now I am going to show this how to compute, how to use neural network to come up with a classifications problem and whether that correctly classify the outcome variable based on activation function, given initial weights, and predictor variables. I want to predict whether this is a like or not on the basis of that. Okay, let us start that. So in that way, you have to predict all of this, but we are just predicting first one in the paper and pencil approach. Okay, so this line number 12 is a predictor variable. Line number 13 is a outcome variable. And then I consider predictor variable as a x and outcome variable as a y. And then I need to sort them. The classes are sorted. Uniqueness, there are two classes, like and dislike. After that, I already run the packages. I put here MLP classifier, where hidden layer size equal to 3. I can give hidden layer size equal to 4 or something like that, or 5. If I put the 5 hidden layer, then I have to put 5 initial weight and 5 initial biases in order to compute that logistic activation functions, which we computed by using paper and pencil approach. Okay. So now let me do that one. And after running that, I find the fit one, and then I want to see the now prediction one. So prediction, I see that like, dislike, dislike, dislikes, like. So see, I did not use any predictive value. I did not use any predictive like the predicted value. I take the complete decisions for the predictions or classifications from input data and then some initial weights and bias theta. and then logistic activations function has been used in order to find this. So activation function used here, logistic. You can also here use linear or exponential. And this is a package, the LBFZH. I mentioned these things. The limited memory, uh, Broyden, Felser, Goldman, and Sano. So these are the people who develop this algorithm. So that algorithm is used for the classification and predictions. Okay. So and then we did some computations in here. CLF intercept. This is the intercept has been computed. And then this is the weights. Weights has been computed. And here prediction has been made. With probability has been computed in here. Like dislike probability has been computed, and finally confusion matrix has been computed. Dislike 3, like. So there is no misclassifications. Like is like and dislike is dislike. So confusion matrix is saying. And then now the next problem is a big data problem. I am running the data. This is my import variable, and then that is the line 38 and 39 converting sart.cont and max underscore save.i. These two variables are transferred to the categorical variable, which we did. Convert the categorical data into dummy variable data. So what we are doing here, changing to the dummy variable data. And that data is name is the process data. From there, if there is a 9 category, we can introduce 8 dummy variable. In that case, we can avoid dummy variable trap. One variable we are deleting that we have created, that like dummy variable. And then I am running here C for C in the process column if C is not in the outcome. So I am doing this predictor variables. From the predictor, I am taking out the outcome variable. Outcome variable should not be in there. Okay. So now processed that is the processed one. This is the outcome variable. After that, I do the test and training. Okay, so let's see what happened there. Hopefully it will work. Yeah, it's worked there. And then I use the solver thing in order to get the solution of this. And then finally I get the confusion matrix results 0, 1, 2, 0, 1, 2. We have some misclassifications and rest of those are classified correctly. Okay. So this is a neural network. I taught it very simple way, very simple, very easy way. And then try to avoid as much mathematics as possible. So this code has been given. And then now if you read the homework problem and run the code, your homework will be very easy. I'm going to stop in here. That's it for the neural network. I hope you enjoyed the semester and class. Thank you very much. Bye.